Hi, today we're going to be covering the zero product property, and it's going to have to do with how we can find the zeros of quadratics. What does that mean, and how does it do with factoring? So we're going to put all this together with this concept here, and again, we're going to be taking notes, so write this down in your journal, and this rule here, maybe highlight this rule. We're going to be using this rule to go ahead and find the zeros of a quadratic. So when I mean find the zeros of a quadratic, really this means that we have this function here, this equation. And really, if you want to give it function notation, okay, this is a function. This is a quadratic function, and it's going to be a parabola. Now, before we talked about absolute value functions, and we talked about the parent value of an absolute value function, and we know that absolute values have a V shape, and we talked about transformations, translations. What does that mean? It means we move the parabola from left to right, the absolute value from left to right. We can make it really steep, we can make it really wide, and we call those transformations / translations. There are more than just the absolute value parent function. There are other families, other types of functions, and specifically here, we're going to talk about parabolas. So the new function we're going to talk about is the parabola. And so this is the parent function here of a parabola. The most basic, simplest form is going to be expressed as f of x equals x squared. So anytime you have a polynomial that has the highest degree is 2, it's a parabola. For example, if we have ax squared plus bx plus c, that is a parabola because the degree is 2. So again, keynote here is if you have a degree of 2, and that's the highest degree in your polynomial, that is a parabola. And it's going to have this shape, a u, a upside, a u, or facing down. So again, it's going to open up, it's going to open down. So again, that's the key thing here, moving on, is we're dealing with parabolas, anything with a degree of 2. Okay? So now we're talking about zeros. When you have parabolas, they can cross the x-axis. If they cross the x-axis, we're going to say that they have possible zeros. What do I mean by possible zeros? Well, really, when we set an equation, for example, when it equals 0, okay, I'm saying, does the parabola cross the x-axis? Then we have a 0. So here we don't cross the x-axis, we don't touch it, so here we have no zeros. It doesn't touch the x-axis. Over here, it touches the x-axis, so we have 1, 0. What does that look like? Well, here it's crossing right there. It looks like it's going to be -2. So again, if I plot this point's going to be -2 and 0. So it has 1, 0. So we're touching the x-axis, we're not crossing it, we're touching it. At one point, we have 1, 0. Over here, we have 2 zeros. Why do we have 2 zeros? Well, we cross. This is roughly -3 for my x value. Over here, this is roughly 1. So again, it has 2 zeros. Why? Because here we have so again, my x value, my y value, we have 2 zeros there because it crosses, right? It crosses, it touches in both locations, right? Those two locations. So again, we're going to move on in terms of parabolas, quadratics, zeros, and kind of bring it together here at the end with this unit. So we're going to solve these two, and we're going to use the zero product property, meaning that if A times B equals 0, it means that A can equal 0, or B can equal 0, okay? Or they both can equal 0. So again, whenever you have two distinct parts, and they both equal 0, that means that each component can be 0, or they can both be 0. So how do we apply that rule to here? Well, we can say that this is going to be one component, a different B component, and then equals 0. So we can say, hey, this is A times B equals 0. Okay? And so the idea behind this, guys, is we're setting this equal to 0 because if you go back to what I said earlier, in terms of let's say ax squared plus bx plus c, let's say equals, for right now, y. Okay, we're going to say y equals ax squared plus bx plus c. Again, that's a quadratic, right? Because it has a power of 2, it has a degree of 2, right? And so really what we're trying to do here is, if I set this equation equal to the y value, okay, this is my y value, this is my x-axis. If I set this equation equal to the y value of 0, it'll tell me if it crosses the x-axis. Anytime that we set this y value equal to 0, it'll tell me if this quadratic touches my x-axis. If it does, then we have a 0. Okay, we have a 0. So here, same thing here. This is not set to y. I mean, we could say, hey, guess what? This is going to be y equals this right here, this quadratic. But I want to know where it touches 0. So I want to say, where is my y value 0? My y value is going to be there at 0, meaning at this x-axis. So anything that touches this line has a y value of 0. Okay? So again, apply this right here, and we're going to say, well, 2x plus 3 equals 0, and 5x plus 7 equals 0. And then I think one thing I want to emphasize here before we move on is, how do we know that this is a quadratic? How do we know that these two are quadratics? Okay? Because if we FOIL that guy, right, if we FOIL it, you're going to get a degree of 2. Right? We've been working with multiplying polynomials. If you multiply 2x times 5x, you're going to get 10x squared. Guess what? Degree of 2, it's a parabola, and if it's a parabola, we want to know where it crosses the x-axis, if it does at all. We call that finding the zeros. So let's go ahead and solve here. We solve here, and I want to subtract both sides by 3. I get 2x equals negative 3. Solve for x. I'm going to divide both sides by 2. 2 divided by 2 is just 1. So then my 0 is going to be at negative 3 halves, which is just going to be x equals negative 1.5. So again, that's my answer right there. I'm running out of space here, but the same thing here, right? We're going to do the same thing here. We're going to make a little line here so we can distinguish between the answers. Same thing over here. How do I solve for x? Well, I want to get 7 over here, so I subtract by 7. Divide by 5. 5's cancel. X equals negative 7 over 5, which happens to be negative 1.5. So this tells me that this parabola, whatever it looks like, it's going to have 1, 0. It's going to have 1, 0. It's going to cross at this location. Okay? So it's going to cross at that location. Right there. And then how do I know that again? Again, it crosses there. Because I have x equals negative 1.5 and x equals negative 1.5, it means that because it has 2 of those values, right, it means it touches at one spot, which means the parabola somehow touches there, okay? And we're going to come back to this value. So again, keep track of your notes. We're going to come back to that. Now we're going to move on to another one. So again, I guess one thing I also want to mention is you need to have quadratics in standard form for us to solve 0. So really, we want to get everything on one side of the equal sign and then 0 before we can solve this. So down here, we have x times 2x plus 4 equals 0. So again, you can say that property, x can be my a, and then this guy can be my b, and they both equal 0. So again, 2 different components. Multiply together, they equal 0. So we're going to do the same approach, right? I don't want to lean down, so I'm going to go over here. I'm going to say that x equals 0 and 2x plus 4 equals 0. And then I solve for x. Well, x is already solved for, so we have x equals 0. So we know the parabola touches down at x equals 0. And we know this parabola touches down at x equals -2. So again, how do we know this is a parabola? Because it has a degree of 2. How do we know it has a degree of 2? If you multiply this 2x by x, you get 2x squared. Guess what? X squared is a parabola. It's a U shape. It can either open up or it can open down. So now, take in mind, we're going to go ahead and graph these two right now. I'm going to show you the graph of these two, and we're going to prove that these parabolas do cross the x-axis at those locations at x equals 0 and at x equals -2. So bear with me. So you can see that I graphed those two equations we were working with. You can see that my head's in the way over here. But these are the equations we had over here, right? So really the equations I'm going to show you here is, I have over here is y equals 2x plus 3, and then 5x plus 7. In order for this to graph in Desmos, I set y equals this, right here, up here, right? Even though in the example we want to say, hey, the question was 0 equals this. When does this happen? When does this happen? And again, the reason why we have 0 to begin with is because we're looking for when this parabola touches the y value of 0. And when does the y value of 0 occur, or where? It happens when it crosses the x-axis right here. This is the x-axis, that line. So anytime you cross this, we create a 0. So let's go ahead and summarize this. To go ahead and graph in Desmos, you must include y equals. Then you look here. Where does it cross? Okay, let's find my zeros. For the first one, in red, we said that we had both x values equal to -1.5. And here it is. If you can't see, I'm going to zoom out. It says -1.5 and 0. That's my point. My y value. So again, 1, 0. My blue one was the second one I did. And that one, again, I entered it as y equals x times 2x plus 4. And then my zeros for that one, we had 2. We said it was going to be 0, an x value of 0, right? 0, which is 0, 0, 1, 0 there. And it crosses over here at the x value of -2 and 0. So we have 2 zeros of these parabolas. These parabolas, again, distinct features, and they open up.